Assalamu alaikum. I hope you all have a nice day. Today we're going to continue the lesson that we began before the holiday, energy and rates of reaction. We began talking about factors that affect the rate of reactions. Let me remind you that the rate of a reaction is a measure of how fast the reaction takes place. Some reactions are fast, some reactions are slow. Now we're going to learn what controls how fast or slow the reaction is. First of all, to make a reaction, we need to break the old bonds and make new ones. So the rate of the reaction depends on how fast or slow these old bonds break and the new bonds are going to form. The factors that we're going to focus on, just like the video that we talked about, but we need to concentrate more on the concept here. The first factor is temperature. Now, temperature controls the rate of the reaction in a way that when we raise the temperature, we usually increase the rate. That means that the reaction becomes faster. For example, in this picture, on your left, we have room temperature water. This room temperature water, in which we put a light stick, glows more than this light stick in iced water. This shows us that the higher the temperature, the faster the reaction. Now we're going to explain why. You know that temperature is related to how fast the particles move. By particles, I mean atoms or molecules, it depends. Now these atoms have some kind of energy, so they move all the time, by vibration or by more movement. When we add more energy, when we increase the temperature, you are actually making these particles or these atoms move faster. And when they move faster, they're going to hit each other more, and this will cause more bonds to break and more new bonds to form. So increasing the temperature increases the rate. On the other hand, the second factor is called concentration. Now, concentration means how much of one substance is in another substance. التركيز. So, what happens when we change the concentration of a substance? In this picture, we actually have two demonstrations of two solutions. On your left, the blue particles, of course, means water or the solvent, but the red particles mean the solute, which is the substance in water. Now, of course, this is low concentration of the red substance. This is a higher concentration of the red substance. If you look at these two pictures, you're going to notice that the chance or the probability of successful collisions or of hitting particles more is more here. We have a bigger chance of more particles hitting each other in the right picture because we actually have more particles, so they have more chance to react. So the rate of the reaction will be higher in higher concentrations because we actually have more particles to interact. The third factor is surface area. Surface area is actually the area of all surfaces of the object. So for example, if we're talking about a cube, the surface area is the surface or the area of 6 surfaces of a cube. Now, when we talk about the surface area, let's talk about this tablet of medicine. When we have a whole tablet of medicine, and if I wanted to react with anything, it's going to take some time because it's a whole tablet. Now, what happens if I break it into half? It's going to react faster because I increase the surface area. The surface area is going to include this inner area here, which was covered in the past. Now, if I